So first thing I'd like you to do today is jump on the blackboard and go to project 2 and the folder that's got all the content in it. And there's a file there at the bottom called sheet format. Just click on and download and save that file and save it with all your other pulley files. So CAID to CAM assignments, project 2, it's at the bottom, sheet format. Save that, save it with all your other documents. Right, so that file type, if you have a look at that in Explorer, it's a SLD DRT file. So it's a drawing template file. It's a bit confusing, but we'll get there. All these different file types. Don't open that file from Explorer. What I want you to do is open up the drawings that we started last week and click on to sheet 1. And at the bottom where it says sheet 1, right click, properties. And where it says sheet format size, tick standard sheet size. And then you can tick browse. So then browse to the file that you've just saved with all your other content. And then press OK. And I thought that might happen. Alright, so I edited that file today at work, which I've got a newer version of SolidWorks with, so it's not letting me open that file. So we'll have to do it a different way, which is cool. Give me a second. Alright, so instead what I'll show you is how to edit the file. I'll upload it and then you'll all be able to download it. Alright, so I'm just going to use a different version.
Should we delete that one?
Yeah, you can delete it because you won't be able to open it.
Mine's worked.
Did it?
Yeah.
Okay. I don't understand, but that's good. You can keep it then. Okay, but for anyone that didn't open, you can just remove it and I'll give you a new version soon. Okay. So in my background on my page, you can see I've now got the sheet format, and it's all the line work on that sheet format. We can't select any of it. Okay, it's all in the sheet format layer. What we're going to do is edit that to add in a automatic link to the part and the description that you can see here. All right, a few of the other things are linked already. So you can see like the date here, that's automatic. You know, that updates automatically whenever you open the file. So when you save it, and if you print it, it's got the current date. The scale is also automatically linked. So if I change the scale on the page to 1 to 2, you see that scale changes, as well as those drawing views. So when you're editing a sheet format, you have to right click on the page and click Edit Sheet Format. And that goes into the edit screen where it hides all the drawing views, and now you're left with whatever is going to show in that sheet format. So you see the blue text here, that's the stuff that's already linked. So some of these are linked to some other properties, which I'll show you soon. What I'm going to do here is the part in the description. I've worked out how finally to link that automatically, so when you put a part on the page, it will link to the file name of that part. So I'm going to select this text, go link to property, and I'm going to change it to the model found here, which will be on the page. So a drawing view specified in sheet properties, and then the property name is going to be the file name. Press OK, and then deselect. Now that text is black because of the layer that it's on. So like a lot of other software programs, there are layers built in. If you want to view layers, you right click and go layer, and it's this little pop up here where you can see the layers in your drawing. So if I go none for that text will now go blue because that's the default color for this layer. Typically you don't do much with layers in SOLIDWORKS. Only if you're doing some really advanced stuff you would have different layers set up, but I've never really worried about it too much. The other one I'm going to link is the description here. So where that part is GA01, the description, general assembly or side plate, etc. We want that to link as well. So link to property, and I go model found here, drawing specified, property name will be the description. Okay, and okay. Now whether it's blue or black doesn't make a difference once we're out of the edit sheet format mode as well. So once I've finished editing the sheet format, I need to accept the changes. And you can see both that text is now black. Now, if I want those changes to carry over and save and reuse that sheet format, I have to save it. So I go File, Save Sheet Format. Now I'm going to save it over the top of that existing file. I might just put that in this folder here. And go Save. And I'll upload that so you guys can download it. So just give me a second. Okay, so try that project 2 sheet format file, just refresh your page so you see project 2 sheet format, download that and then load that in. So once you've saved that to your folder, how you load it is you right click on your sheet at the bottom of the page, press properties, make sure a standard sheet size, press browse, and then browse for that file. Yeah. We'll try and work that out later. Okay. So, any existing pages that you have in your drawings, you also have to upload or update that sheet format individually. Okay, there's no way to do it across all of your pages automatically, without having a macro, of course, but we don't have that at this stage. So just for your other pages, do the same thing. All right, so you should have that same sheet format. Now, once that sheet format's loaded into all of your pages, when you want to create a new page and you press new sheet or add sheet, that next sheet will also have that sheet format there. Right. Now to explain what that change has done to our drawings, I'm going to insert another part drawing. Now for this one, what I'm going to do is open up this part 1. So I've got PO1 open. Yep. And on sheet 4, I'm just going to add a standard 3 view of part 1. Now, to get the part name and the description to link on this page to those drawing views, I have to right click on sheet 4, go properties, and at the bottom here, uncheck where it says same as sheet specified in document properties, and then I can select one of the drawing views that's on this page. Now it's going to be one of those bottom 3 views there. I think, or it might be 9, 10 or 11. To check what you can see, if you click on the drawing view, either the front, top or side view, you see they've got names associated with them. So this is drawing view 9. You can also see that on the side of your page in what would be the feature tree, but for the drawings. You can see on sheet 4, I've got these 3 drawing views. So I've got drawing 9, 10 and 11. So I want to link these properties here, the part in the description, to one of these drawing views. So let's link it to drawing 9. Uncheck that, click on drawing view 9, okay. And you can see that now links to the name and the description of that file. Okay. All right. I'm glad that's worked. I've been trying for years to work out how to do that. Save all. Okay, so a bit more about sheet formats. We used to spend a whole class where everyone would create their own sheet format, but in the end what we've sort of decided on looking at the semester for the class is that when you get a job somewhere, they will typically have a sheet format set up, as some of the examples I showed you last week. So spending 3 hours or more creating your own for a project like this is not really worth it. So instead, we supply you with this format, but I'll just show you some of the basics. So all the line work that you can see on this page, that's done with normal sketch lines. All right. So, if you wanted to change any of the line work, you can just select it and delete it, or sketch the new line. So if you want to create your own lines. They're hidden at the moment, but sketch relations are also used. So, sketch relations. So you can see a lot of these lines, they're coincident or they're vertical. You can do, if you're doing some sort of, grid, you could have equal spacing between all the different boxes. There's things you could do like that. The letters that you see on the side, the coordinate system, they're just normal annotation notes. So you go annotation note, click the box, and you can type in a letter, and you can copy and paste those letters. And if you have enough of them, you can also do a linear note pattern. So you can select one and just pattern it a certain spacing. So the coordinate system, that should be pretty self-explanatory. If you've got drawings that you're sending to a supplier or a client and want to speak about a certain detail, you can say, yep, look at this zone on the page. This here is a logo or image brought into the page. So to insert an image, you go insert picture, or you go tools, sketch picture. And then you can browse to a file, like a JPEG, go open, and it's gonna put that in at 0, 0, which is this bottom left corner. You can then drag that image, you can resize that image. When you're happy with it, you press the tick. All right, now if it's got a white background, when you print your page, it's just gonna look white. Right? The settings of SOLIDWORKS drawings are to show a paper colored background, but when you print it, it's white. To edit that image again, you just double click on it, and then you're able to move it. Or if you want to delete it, you just select it and hit delete on the keyboard to remove it. This is a third angle orthogonal symbol, which explains the type of view layouts that we have. So when you click on your sheet and you go properties, you can see type of projection, we're using third angle, whereas other design disciplines may use first angle for their projection system. It's important in your drawings to always have units of measurement and information to say do not scale drawings. It seems really obvious, but you should have that in there if you're ever creating your own. The other information you put in is really up to you. You saw on some of the other examples that I showed last week where there'd be client information, there might be material or weight properties or finish information, copyright information. It's totally up to you. So here we've got some information which is just normal text, which is always going to remain the same. This other text, this blue stuff, is linked. So they're linked to custom properties. So where custom properties can be found is on this button here at the top, File Properties. And you can see the summary here, but under the Custom tab, you'll find the custom properties for this file. So whether your file is a part, assembly, or drawing, it can have custom properties added to it. And there, when you save, let's say, a part template or a assembly template file, it can save those properties in there. So when you ever open a new part based on that template, you can then go to your properties and just add the information you need to. All right, now this has some information that is carried over from some previous projects. So things like revision date, revision description, revision date, P number, they can all be removed. And part and description we can remove as well because we don't need them to be editable anymore. So what you're left with, you can see there is project, class, student name, student number, title, and you can see the information currently in those boxes. So to show you how this works, I'm just going to add a new property. Let's just say material. I don't need you to do this, I just want you to see how it works. And I'm just going to put XX in there for now to leave it blank. Press OK. So if you wanted to have a text box linked to that property, you create your text here. So there's my box. Now, if I want to format it, I can, pick the size, I can pick the font. If I want it bold or in a certain color, I can do those things. You select the text like this, make sure it's highlighted, and then you do the link to properties that we were doing before. And you leave it under current document, but you here on property name, Dropbox, you can then look for the one you've created, which is material. Press OK, and OK. You can see the text is updated. So what happens now, if I go File Properties, I add in the material there, carbon fiber, press OK. That's going to update that information. The way that this works is this will update, if this is in my sheet format, all right, and let's say I just put it here in a corner and I said material. When I save the sheet format and reload it across all the pages, that information will be in the same place on every page. So this only works if my material note is going to be the same on every page. So if I've got different parts with different materials, then it's not going to be useful, all right, because you won't be able to have different properties on different pages. To do that, we need to do what we did with the linking of the part and the description, which is a little bit different. So when you are adding information like this, it comes down to properties that will be the same across the whole project. So in our case, this is going to be project 2, all right? It might be project 3 or whatever else you might be doing. The class, okay, the class isn't going to change across the pages. Your student name and student number. So you can put that in as well, or update that information, okay, in the properties. All right, that information is going to be the same across all the pages. So that's why it's here, and this saves you from having to edit each individual page to add that information in. As you can see there. Some of the other ones here, like scale, sheet, and date, they're a little bit different. Okay, they're not, they're custom properties, but they're linked to things built into SolidWorks already. So some of those ones, to create them, again, just start with a text box and select the text. But when you go link to property, you don't have to select anything else. Just go to this drop down. All the items with the SW next to them, SolidWorks, they're built-in ones that are automatically linked. So you've got short date here. So that's going to have a short date, as you can see there, matching the one here. that's the current date, all right, as you can see on the computer in the bottom right corner. There are other ones like long date, or last save date, or last save by. All right, they're a little bit different. Okay, so this file was last saved at 5:51. Things like scale, sheet scale, pretty obvious. So you go down and you can see view scale, or there's sheet scale here. So 1 to 2. Sheet number 5 of 5. That one's a little bit different. To do that, I'll just do a new note. We need to link 2 separate pieces of information. So first up, we select that first letter and go link and properties, and that's going to be current sheet. So SW current sheet, which is whatever page we're on, that'll be that number. Then we select the last one. Got to press OK first, so make sure I go current sheet OK. Then I select the last X, same thing, but this is going to be total sheets. Okay. All right, so when we're on, page 3, you can see it's 3 of 5. Okay. So you can link text in the same box to different properties. All right. Once you're done with that, you can always select it, change the styling, and just move it into position, and that's done. So when you are done with that sheet format, to save it, accept the changes, and then any changes that you have done, you need to go save sheet format, save over the top, and then reload each of the pages. So if you haven't changed the file name, you just go properties and you press reload, and it just updates the information. All right, and that's the basics of sheet formats. Any questions on that area at all? So you don't have to do any editing of the sheet format for this project. I just want to give you a brief rundown on how they work. All right. So now that we've got those sheet formats in there, we can go back to the first 3 pages that we were on last week, and we've now got some challenges to try and get them to fit on the page. On this first page, the General Assembly, it's going to have to be 1-to-1, or we want it to be 1-to-1. So what you're going to have to do is reposition your parts and work out a way that you can get these front, top, and side view to fit on the page. Does anyone have a suggestion for how we could do that? Yep.
Problem is it's too long,
Yep.
too high, so if you were to change the first view, then the top one would be flatter. I'm not sure if that, so if you
Yep.
change the first view
Orientation.
to a view that's fat from
Yep.
the side,
Yep.
then the top view will be...
Yep, spot on. So because of this angle, all right, that's not going to fit on the page, but if we've got our top view sort of here, that will be able to fit. But we still want to keep this as sort of the front view. Whether it's front or side doesn't really matter that much. So we can just here change the orientation to the right view, press yes. That'll rotate them all around, and then I'll be able to drop this down. Now, another reason why this doesn't fit on the page is one of my dimensions is still pretty wrong. This form bracket is quite big, so I'm just going to edit that part, fix the dimension. I think it should be 37.5. Save, update. All right, now that fits a lot better on the page. It's still pretty tight. I might be able to do some further adjusting later on, but that's the basics of how to set out that page. We'll come back to view labels and dimensions later. Sheet 2, depending how you've gone last week with your angle, you may be able to get that to fit. You can see mine's just fitting up the top there. But that's your task for this part, to get it fully exploded at an angle where none of the parts are overlapping. Sheet 3. Now this is a bit of a smaller one to fix. So when you have a section view and it has that line going through the part, you can actually resize that line. So at the moment it's going up into my bill of materials box. But what I can do is grab the top of that line and just drag it slightly down. You can also click on the letter and move the letter as well. So I can just move that to the side. And do the same at the bottom, just squeeze that up and move the letter into the side. Whenever you move that section line or select it, the section view is going to have these hatches over the top. What that means is it needs to be updated. All right. Sometimes if your section line wasn't already locked to a certain position, then it will have actually updated the section view. So just have to be careful of that as well. In our case, there's not going to be any change. I just need to hit rebuild or Control B to update the page. It'll rebuild the drawing view and then we lose the hatches. The other thing I can do on this page is the bill of materials. I do still have to sort out that issue with the nuts and bolts. Okay, that's caused me a few issues, but yeah, might come back to that later on. One thing we will do on this page is add 2 custom columns, and these custom columns will be material and finish. Now for these ones, we don't need to go through the process of linking the properties to the files. Okay, that's a sort of advanced thing that you could do, but we're not going to worry about that. All I want you to do for the bill of materials is to have all of your parts in there, so sub-assembly and then 3 to 9. For this information here, material and finish, I just want you to add in custom information. So for the side plate here, that's this part 3 here. Now the thickness of this part is 2 millimeters. So here we can type in 2 millimeter and we could type in the material. Now don't stress too much about it, I'm just going to do mild steel. You could make up any material you want and any finish you want. I just want to see that you're able to create the bill of materials and add in custom information. So repeat that process for the other parts. For the sub-assembly, what do you think we should do here? To communicate the information about the material and finish for the sub-assembly. No ideas? No ideas? No ideas? What should we do to communicate the material and the finish of the sub-assembly parts?
Refer it to the sub-assembly page.
Exactly. Refer it to the sub-assembly page. We'll come back and update that later. All right, but on the sub-assembly page, it's going to have its own bill of materials. In that bill of materials, we'll have the material and finish information for those parts. On this page, just got to refer it. All right, so it's really just sort of common sense stuff that we're going to add in. So we'll come back to those later. Okay, I'll edit this later as well. Make sure you save regularly, just in case we have any big issues. Section view label, we need to move that up too. So what I'm going to show you now is how to lay out a page for one of our parts, and then how to do some dimensions and annotations, and then I'll leave that demo for a bit and come around and help you guys out. So for this part, when we're doing detailing for one of our parts, the best way to think about it is the way in which it was communicated to us to begin with, and what dimensions we used to build that part. So when we built this part, we did it with the revolve at the bottom, we did it with the loft in the middle, and then there's the hole and some fillets that we have to add in as well. A standard 3 view is not going to provide enough information for someone to accurately, measure or work out how to build this. Now, in reality, this part's going to be done. We're going to do some samples on a metal lathe. It's going to be a little bit different, but we need to just try and imagine how you would dimension some of these details, or for someone to check them, how they might, be able to create a mold or some way of verifying the design that they've created. So first up, we'll do a section view. So we'll do it on this front view here and just select that hole as a center point. That section view just gives us a clear area here at the bottom, which kind of matches the revolve. Okay, the section on the revolve, for us to dimension some of these faces and angles. So we'll come back to that one there. To do the ellipses, which we used on the loft, we're going to have to do some section views going the other way. So I'll go horizontal, and I'll go click one here, and just drop that up there. And I'm going to do another one again at that center point. So that's the plane where the 15 millimeters was. I'm going to right click on these views and go alignment, break alignment, and just reposition them over here. And over here.
Did you get the right location for those horizontal ones? Did they snap to that or?
I'll come back to that.
Okay.
Yep. I'm just sort of laying out the
Yeah.
drawing views, and we'll sort of refine them soon. If I do a projected view from this, that'll be an isometric view. So I'll just put that in the corner. And okay, so we'll fix up some of the details. So on these section views, I'm going to flip the direction so it's facing down and facing down. Just gives me a better view of the part, I think. And just to align our drawings and just to get it neat, I'm going to align this horizontal by origin with this top view. Okay, so these section views can actually be in line with this top view here. They don't have to be perfectly in line with the ones below. You can just get them sort of close. You can only align one view with one other view. You can't align it with two. So I can't go align horizontally and align vertically, just one or the other. All right, so to get these in the right spot, well, this one here was easy because I could drop it on the center point of the circle, right? Which we know is basically that 15 mil plane already. This bottom one, not so sure, but what we can do is add a dimension to that section line. All right. So when we're doing sections in drawings, it's the same way we do them in sketches. Annotation smart dimension, or right click, drag up, and you select a line and it'll create a dimension from that line. Now that little icon that you see come up with the two blue halves, that's just basically a shortcut way of dropping that dimension either on a right or a left, or if you're selecting a circle, you'll be able to select quadrants. So you can go, northeast, northwest, southeast, southwest to drop it. What we've done here is done it between the line and the section line. Now that has to update. I'll just press rebuild. That section line is now at the same point where our plane was, which means that that section view CC is going to have an ellipse which is 18 and 12, exactly the way that we sketched it in the part. I'm also going to add a dimension here between the two for 15. Now that top section line is already defined by the center point of that circle. I can make this driven, press OK. And this is some information that's communicating what we had in our original drawings to us, the 2 mil and the 15 mil planes. I'll come back to how to dimension the ellipses soon. All right, so they're the basic views that we need for this page. Every page, every drawing view should have a view label. So that's what we're going to add now. You can see the section views have them automatically. For the other views, we need to add them. So there's no shortcut way of doing it. Do it manually. Select note, and then with the annotation, okay, you get this box that you can see next to my cursor. What you want to do is drop that on one of the drawing views. Okay, so if I just drop this on the side view here, and type in side, and then click again with the mouse, I can then drop the next annotation on the top view, and do one on the front view, and isometric. Now just to show you what happens, I'll drop another isometric one here on the page. When you drop annotations and dimensions, you'll typically always want to drop them on a drawing view that they're going to be linked to. So this isometric view label here, you can see it's linked to that drawing view when I hover over it, whereas this one is just loose on the page. If you want it to link to one of the drawing views, drop it on that box so that when you move that drawing view, the text will move with it. If you don't drop it, it'll just remain separate and basically floating. Once you've dropped that text, you can then select it and reposition it. So one of the things we'll be going for with our drawings is consistency. So on every page, we typically want to have our view labels in the same position, okay, relative to their drawing views. If you want to get very pedantic about it, you can select text and you can align it. Right, but I'm not too fussed about that. So that's using the align toolbar, which I've popped up on the side here. Okay, so how to add dimensions. So we're going to add some information here to our revolve. So we can start off just by selecting some of the basic edges. And we'll do the angle as well. We can do the 5 mil there. And what will happen if we do every single dimension that's available here on the one view, it can start to get kind of messy, okay, and hard to see all of the detail. This is when you need to think about your page as a whole and work out where you can spread some of that information around. So on our other drawing views, on our top view for instance, we've got the outer diameter of that circle. So I can put that 20 millimeter diameter on the top view. When it's up there, I don't need to put it down here as well. All right, I can take it off that view, press delete. So it's one less thing I need to put on that view. This radius of 12, I could just as easily put that on the side view. All right, which again means I don't need to have it on this one. Same with this 10 diameter or the 45. So if I want to clean up that, I could definitely put one of those views onto this side view rather than the section view, just to keep this a little bit clearer, a little bit easier to understand. So when you're doing dimensions like the one on the angle here, if we want to dimension this height, where you move your cursor, you'll get a different measurement, okay, just like you would when you're sketching. So again, just move that one to the side, move that one up. Is that all of the detail around the bottom revolve there covered off? I think so, but if you're not sure, what you can do is right click here, open the part, click on the revolve, and you can see all the dimensions included. So we've got the 12, the 45, the 10 mil, which is like that 20 mil diameter, 5, 6, and 3. So I think we've got all of that covered here. So we've got 5, 6, 3. We've even got a 5 mil in here, just to explain that. 10 mil across the middle, 20 diameter at the top, 45 and 12. So that's most of our dimensions covered. So the last one I'll show is just a little trick. On the ellipse at the top, where we've done this section view, when I try and dimension that, it says the selected entity could not be converted into a line or a circular arc. Basically, when you do a section view, even though it's showing an ellipse there, there's no actual sketch or edge for me to dimension from. Right? It's just a visible line on the page. So if we want to show that ellipse size that we had in our actual sketches in the loft, we have to fudge it a little bit. We can do that by sketching an ellipse on top of that edge. And when you have that ellipse sketch there, we can then do 18 and 12 on top of that. That line won't be visible because there's already an edge there, but we can now have those dimensions showing. On this one, it's similar but a little bit different. Now the other point in this is, if I had this section view flipped, looking upwards, I no longer have a circle to find the center point. Right, see, there's nothing snapping around here. Whereas if I flip that and I have that circle view, I can see that center point come up. Now when you're doing your ellipse, be careful not to snap it to this edge. You can see the dimensions next to my cursor. They're saying a radius of 9 and a radius of 6.5, which is not correct. It should be 6. That edge is not the ellipse shape. Instead, just drag it out a little bit further, and then when you add a dimension, you can manually put in 12 and it'll resize that ellipse. 18. Now if that's twisted, you would again just want to make sure it's straight. And then this line, you can change it to for construction. Right. So it's just showing the detail there about those two ellipses. The last thing we would do if we refer back to the original drawings, remember there were some notes here just communicating that information to us. Ellipse A located here but 90 degrees to ellipse B located here. This sort of annotation is what we would put on our page to help communicate that information in the drawings as well. So if we go to the section views, we could actually you could potentially rename these section views. So that could be section of ellipse A even. There are different ways of doing this, but you see how that works there, maybe not that way. I'll let you play around with that and see what options there are. Let's see. But the annotation, we could add a note here that points to this section line or the edge that's close to that. And you can write in the information and have it linking to that view. Okay. All right, so with the examples, I just want to make it clear, with the examples I'm showing you, I'm not going to show you every single detail on every single page that you need to add in or that you need to try and get the best mark. I will show you a couple other pages and views But in a lot of cases, you need to consider what information is relevant, what dimensions are required, what type of views should be on the page to communicate that information. So this is sort of the starting one where I'm showing you most of it, but other pages like the reinforcing plate, form bracket, pulley wheel, side plate, the number of views are going to be different. All right, the types of views might be different, and any annotations might be different as well. Okay, so you need to put a little bit of thought into how to lay those out. So have a go at the first one here and refining the other pages that we've started. I'll have a break now. I'll come around and just help you guys out, and then we'll come back to this in probably another 20 minutes or so and work on the next steps. Okay, we'll continue on with the next sort of steps now. So I've shown some basic dimensions and annotations on this page here. So when you're doing your dimensions, key things to remember: keep your dimensions off your drawing views. What that means is don't do a dimension like a circle here and leave the number or the note on the drawing view. Always have it off. And when you can, try and minimize any overlapping. So, you know, don't have a bunch of numbers all really close by or a lot of really small dimensions in an area. Spread them out where you can. So every view that you have in your drawings requires a view label saying what it is, either a section or section and detail views will be automatic. The other ones, you'll have to put them in manually. And then with dimensioning, okay, for each of your parts, you're dimensioning all the details they're required to measure or check the part. With the assemblies, it's a bit different. On your general assembly page, we're only going to go with 3 dimensions, basically a length, height, and width. Reason being, all the details is already covered off on each of all the parts. On your assembly page, you just need the information to convey how big the object is. That information might be used by the client to say, you know, for their website, how big the product is, what size rope it can hold, or for packaging, how big the packaging needs to be, those sort of things. So on this page, the only dimensions we need are overall width, which you'll see there is the 80, and then overall height. Now, if I try doing the height, I can try from this side view, from the top of that pivot pin to the wheel. Now, when I select there, it's going to take me to the center point of that arc, which I don't want. If I press escape, I'll just go back one. Hold shift when I select that bottom arc. Still won't work for me. Just got to make sure I get right on that bottom edge, and then I'm able to get an overall. And then we want an overall sort of depth or length, which would be basically the size of the bolt there, 55.4. So this 80 here, this width, we might be able to do that in a different position or move that dimension here so that it's still on the page. And we need to add our view labels. So unlike the other pages, we might not be able to fit the front view label underneath this drawing view. As long as it's in the region, you know, around the bottom area there, and I'll actually change those around so that can be front, side and top, doesn't matter. But just have it in a consistent position. So, okay, bottom right corner of each of those views. And then isometric. All right, so I'll be looking for consistency across your pages and how you lay things out. Okay. So we'll touch on dimensions and annotations again later in the project, what I'd like you to do for the rest of the pages is to really just lay them all out. Okay, try and get all the drawing views you think you need. And when you think you're done with a page, if you've got questions, ask someone around you or ask me, and I'll point out to you what you might be missing. Okay, but I'm not going to tell you exactly what you need on every single page. You need to do a bit of thinking about it, okay, about how to present that information. To help you with that, if you're unsure about the way of thinking, there is some references on the blackboard. So there's this drawing method reference here. Now, this is an old document which talks about how to lay out drawings. Talks about a few things that I've mentioned already. Who's the drawing communicating to? What do they need to know? So these are the things you would think about when you're laying out each of your pages. The object views, the line work. Now, line work is set by default by SolidWorks. You don't really need to edit that. Dimensions, text, the title block. Again, title block's already set in the sheet format. But the pages and information this links to is what's called the Engineering Drawing Handbook. Now, that's a textbook that used to be a requirement in this class a long time ago. Not so anymore, just because with so many different manufacturing technologies now where you basically send off a file and get a part made, you can skip half of this stuff. But it's still here for reference, and I've actually scanned previously a couple of these pages which talks about dimensioning and tolerances, how these sheet formats are laid out, how the default text size is set by certain standards, line types and their applications. So if you're curious about this stuff, have a read through just to get a bit of an understanding of where all the standards, it's called AS 1100, have come from in the past. Most of it's taken care of now by the default SolidWorks properties. So it's lucky for you. If you're ever looking to find where things like line weights and text, default text size is contained in SolidWorks, you need to go to right click on your document and go to document properties, and that will bring up this box here, document properties, drafting standard. So there's two things. There's system options. System options relates to SolidWorks on this computer, and that will go across different files. So things like file locations, performance, drawings. It's basically a lot of options where you can turn on or off. Document properties is linked to the file that you've currently got open. And this is where you can change things like the annotations, so your notes. So you can see the standard for notes here, it's based on ISO, and there's a thickness here, and there's a font, and if you click that, there's also a font size. There's defaults for the anchor position. You can change here the types of arrows. So if you wanted to set out your own standard that you're going to have across all your drawings, you could go to the document properties, change all of this, change all the notes. You could go to dimensions and you could say, okay, I want all the dimensions to be 0.1 of a millimeter. You can change that. You can change how the dimensions look when they come off at an angle. Okay, is the text going to be horizontal or vertical? Is it going to be centered or left or right? Basically everything that has a default setting, it's built in here. So line fonts is where you look at those thicknesses. So everything in that drawing handbook that says the different thickness for the type of lines, you can see they're already determined here. When you're done with those changes, go to drafting standard up the top and you can save it as your own standard. So if you're doing your own projects, your own drawings, you want to have a certain appearance with the drawings that you present, create your standard, save it, and load it into your default template file. So whenever you start a part or a drawing, it's already got that standard built in. Of course, you don't have to do any of that for this project. You can just work on the standards, but for future reference, that's where you can find that information. So, what we're going to do now is look at a bit more modelling. So, some of the advanced features that are going to tie into the prototyping part of this project. So what I'd like you to do is open up your assembly, and while we're here, if anyone had any dimensions that they wanted to check or questions about any of these parts, you could bring it up now and we'll edit them and look at them on screen. So did anyone have any questions or parts they thought they had wrong?
The height of the form bracket you mentioned before.
I think it's 35.
Yeah.
So I've just changed it then. So the key with that was looking at this shape, how it should just pass over that edge. All right, but you've still got enough clearance around there. Anything else for anyone? No? Okay, cool. So what we're going to look at now is called configurations. So to explain configurations, I'm going to show you an example. I did show some very quick examples in those strollers that I showed at the start of semester or a couple of weeks ago, where you had the fully assembled version and then one that would fold flat. So that's in an assembly how configurations can work. In a part, they're a little bit different. So I'm just going to design just a basic table. And what we're going to do is make 3 versions of the same style table. So we'll just pick a size here, 600 by 400. And the thickness might be 40 mil. And I'm going to offset that 500. Maybe it's a bit much. It's going to be a kid's table. 300 off the ground. And then on that top plane, I'm going to have some legs. Now, there's a setting that I normally have on my own computer, which I'll show you guys how to turn on now. Go to Tools, Options, Sketch. There's a box here that says Enable On-Screen Numeric Input on Entity Creation. Tick that. And tick this one, Create Dimension Only When Value is Entered. This will save you a lot of time. What it means is when I create a shape, I've got dimensions automatically there, and I can just type them in 50 and press tab to swap between them. All right, that adds the dimension, it even adds the equal relation for them as well. So instead of having to then go grab the dimension tool and add these relations, it does it automatically. I'm going to mirror that one around. And extrude up to next. Merge. Okay, so that's my base table, my first version. So, I've got that in my configurations tab here at the top, configuration manager, I've got a default version. I'm going to add another configuration. So I right click, add configuration. This next one's going to be the medium sized version. So on the medium sized version, it's going to be bigger. First, the height of the table is going to go up to 600, and the thickness is going to increase as well to 60. To do that, I just have to tick this box here that says configurations linked to this configuration. So that links those features, those dimensions, to the configuration I'm currently in. I'm going to also edit the sketch and make these numbers bigger. So the 600, now this can be difficult. what you have to do is not click on the number, but open up this modify box, press this drop down, link it to this configuration. So what this is doing is linking the dimension that I put in now to this current configuration. This is going to be 900, and this can just be 550. Okay, and the legs, the height will stay the same, but I'm going to edit the dimension. Link to this configuration, that can be 80. And then I'm going to add one more configuration. Add configuration. This could be the large one. And for this one, because I've already linked it to a specific configuration, this one will be linked separately. So I don't have to bring up the modify again. You can see it's already linked to this configuration, so I can just leave that and just change the number. It's only if there was another dimension that was different that I would have to change it. The height is actually going to just change it a little bit. 600. 550. Okay. So, how the configurations work is you can flick between them. So if I double click on default, it goes back to the small version, medium, and large. All right. Now in this situation, I've just got two features which have now different dimensions in them linked to those configurations. Okay. The real strength of configurations is the ability to add details that are only linked to certain configurations. So on the large version, let's say this is an outdoor version, and I want to have a hole for an umbrella. So I'm going to put in here a 120 mil hole, which is going to cut all the way through all. Now, when I click on the default configuration, you can see that's not there, that hole. If you have a look at the feature tree, you can see cut extrude 1 there, and it's grayed out. Now what that is suppressed. So when something is suppressed, it's turned off. If I want to unsuppress it, I right click, and I've got this icon here, unsuppress, or in the drop down, sometimes be there, but unsuppress, that turns the feature on. So you can have a configuration with the feature on, like it is here, or you can have it off. Now the way that things will update when you add the details is determined by the properties of that configuration. In properties here, under advanced options, you can see it's suppress new features and mates is turned on, right? Which means anything new that I add to one of these other configurations won't be added to that medium-sized table. So if I now added a detail on this one, for instance, that filleted all of these legs on the inside, let's just make it a bit bigger. Do the outsides too. All right. Go to the medium configuration, and that's off. But if I want to turn it on, I can just go here, unsuppress, and now that's on. So now I can have the default, which is the small kitty one, without the hole, without the fillets. Okay, that's the simple version. I can have the medium sized, larger with the radiuses, and the larger again with the radius and the hole. All these types of features generally have a setting where you can separate or change the dimensions to that configuration. So in this one here, under the fillet parameters with the size, there's the drop down here, I can link it to this configuration and change the size. Now if you see that traffic light symbol, that means rebuild. Have to hit the button up here, rebuild. So this enables you to have one part, okay, and you might have a certain style to the thing that you've designed, but you can have multiple versions. Right? How this relates to our project is for the prototyping part of the project, everyone's going to be assigned one part of the pulley, and that part of the pulley you'll be individualizing. Okay, so you'll be making a different version. However, we don't want that new version to override the drawings. So the drawings are going to be about the pulley that we made in project 1. Everyone's will be the same. Right? But the prototyping part that you'll actually make will be different. It'll be a new version. Instead of creating 2 separate files, we keep the same file, but we're just going to add your own version of that part. So I'm going to show you how to do that now in your own files. And we're going to use the subassembly as an example of that. Right? So I'd like you to open that subassembly file up. Holes are too small. Should be 13.2. And go to configurations and right click where it says subassembly 101 configurations and go add configuration. And this new configuration we're going to add is going to be called prototype. And press OK. So in our prototype version of this part, we're going to have a customized pivot pin. And also we're going to have no washer. We're actually going to add in a split pin, which looks a little bit different. So in this prototype version, you can suppress the washer. So if you go to your feature tree, click on the washer there or in the viewport, and you can press suppress. Okay, now that turns it off, but it doesn't delete it. So to check if that's worked, just go to your configurations, double click on default, and that washer should just come back, turn back on. Next week, we will look at how to edit this part. There's some specific dimensions that we need to have for that pivot pin. So we're just going to leave this configuration or this subassembly here. All right, just the basics of it. We will though go to one of our other parts to customize it for prototyping. And so for the example for that, we're going to use this side plate. So on the side plate, do the same thing. Add configuration, prototype. Right, 'cause this is an easier example for me to show everyone how we're going to be doing it. Okay, so with this part, what we have to keep the same is the 2 holes, A and B, and that dimension of 76. We will also keep the thickness, we will actually increase the thickness. So that's the first thing we can do. So this part's going to be made from 3mm acrylic. So if we want it to be realistic, we can link this boss extrude 1 to this configuration and change that thickness to 3. The second part that's going to change are these holes. So we need to keep A and B the same, but we want to get rid of the rest of the holes. What happens if we change the sketch, Now let's just say I turn these holes off by making them for construction. That's going to affect both configurations. So that doesn't help me. All right, I need to keep the sketch the same. Instead, what I can do is add some more features that I can then turn on or off to remove those holes. Now, if we wanted to fill in those holes, what's an easy way of doing it?
Suppress the
No, because that's going to suppress all of the holes. I still want to keep 2 of them. So what's another option?
You delete the relation.
Delete what relation?
The relation to the pattern.
Well, the pattern is part of the sketch that is part of this cut extrude. So I would have to go in and edit the sketch, but as we saw, editing the sketch will affect both configurations because it has to be on to keep the A and B hole. So my design intent here is to fill in the 5 holes that are the pattern. What's an option to fill them in?
You could do a whole nother sketch which was exactly the same thing but like a negative version of it. That was just like 5 cylinders extruded to the same depth.
Like that.
That was quicker than I would have done it.
Yeah, but that idea is spot on, right?
Yeah.
So if we want to fill in those areas and it's just a flat face, then we can do the sketch. So what I did was convert entities. So I selected sketch number 4, press convert. I deleted the sketch that had converted these 2 holes because I don't want to fill those in. And then I did an boss extrude, which goes up to that edge or that point. So if I flick back to the default configuration, you can see that's still got the holes, but this one has removed them. There's another feature I'll show you instead of that boss extrude, which is a little bit different. It's one I've started using more recently. It's under Insert Features. Actually, it's not on this menu, so we're going to add it. So I think I showed you a couple of weeks ago how to customize this toolbar. It looks like it's reset since then, but that's not a big deal. The one I'm going to put in is called Move Face. Just have to work out where it is. Or move or delete face. Sorry, delete face is what I'm looking for. That'll be under surfaces. Delete face, there we go. So delete face, it's a surfacing tool, but you can use it on solids. And removing holes is an example of something it can be used for. If I select these holes, the face on the inside of them, and for delete face, I select delete and patch. Preview on or off doesn't do anything. It's going to remove those faces and then patch up the surfaces that are left on the outside. It does essentially the same thing, but I don't have to create a sketch first. So it's a little bit quicker, just that tiny bit quicker. All right. Okay, so with that done, we can now create our modifications to this part. So what I said before, we need to keep those holes. We've increased the thickness. Now you can create a sort of pattern. Okay, so in the examples that I had previously, or that I showed last week, it was just really some cuts. So just come up with something very quickly to test it out. Doesn't matter what, we can make it more. You'll be able to refine it next week when we do the prototyping stuff. Actually, just do clean this up next week. I'm going to do a cut extrude. I'm going to cut these areas, and then I'm just going to make a selection. Might not work. Won't be able to do all of these. But okay, so there's my custom part. So I've got the default and I've got the prototype version. So if we want to see what this looks like in our assembly, we can now go to our general assembly. In our general assembly, again, we want to create a prototype configuration. So we've done one in our sub-assembly, which we'll come back to next week. And now we've got one in the general assembly. What we have to do is select the part that we're changing and change the version. So on this drop down, I've got the prototype version of that part. Press OK, and you can see it here, the difference. So the same with the sub-assembly. The sub-assembly has a prototype version as well, where at the moment the only difference is that the washer is missing, but eventually that'll have a bit more difference to it with the pivot pin. Is that making sense how the configurations work? Yeah? So we'll have more specific requirements about the changes you can make to your parts next week when we do break into groups and do the prototyping. But for today, while it's fresh in your mind, just have a go at that, okay? Either creating a new part from scratch or editing one of the existing parts. The other thing that we're going to look at now, because it does come back to, and it does affect our drawings, and it will actually affect some of our assembly as well, we'll have to redo some mates, is this form bracket. Now for the form bracket, what I'd like you to do is open that up, and we're going to convert this to sheet metal. Now this is not specific to the prototype version. This is going to be used in our drawings as well. So for this reason, we don't create a separate configuration for it. We just leave it as is. I'm just going to give you a quick intro to sheet metal to show some of the basics of it and how it all works. So first up with this part, to convert it to sheet metal is very straightforward. Right click on our command manager up here and turn on the sheet metal tools. And you can see on that sheet metal tab, most of the options are grayed out, but some at the front and the end here are on. Base flange tab creates, that's how you create a sheet metal part from scratch. Convert to sheet metal is where you convert an existing part, and that's what we're going to use. So hit convert to sheet metal and select, in the first box here, we need to select our flat face. So we're going to select that one at the top in the middle. The preview that you can see, the yellow, is the thickness of material. So on the settings here where it's got T1, change that to 3 millimeters. That's the thickness of our sheet metal part. The internal bend radius here, we can set that to, I think it's 2 millimeters at the moment. But what you'll find is when you've got a part like this already designed with a radius, when we select the next box here, which is our bend edges, we can press collect all bends. It's going to tell us you can't change the radius of pre-made bends, okay? Because we've already added that filleted in, we can't change it. Press OK. You should see then the part's all yellow. Press the tick. The only difference is this has added some lines to the part, but it's also added in our feature tree a sheet metal feature, a convert solid feature, and a flat pattern folder. And under that flat pattern folder is a flat pattern feature, which includes bend line, bounding box, and 2 flatten features. All that is added automatically by the sheet metal tool. The key with this now, you can see the other options are on, including this one at the top that says flatten. When you press flatten, your part's going to fold out flat. Now, when you hit that button, what it's doing is unsuppressing the flat pattern feature down here in the feature tree. So where we were talking about configurations, when you do sheet metal with a part, you convert it to sheet metal, it adds a flat sheet metal configuration. Normally it's viewable here, maybe it's different in this version. But basically hitting flatten opens up the flattened configuration. Okay, now that includes bend lines here as well. So in your drawings on your page for this part, what you're now able to do is add a model view of part 04, and you can select that model view and select flat pattern as an option. Okay, and that's how you can create this flat pattern view of that part. On that page you should still have your standard 3 view parts and an isometric. Okay, but you'll also add in that flat pattern. Now that flat pattern view, if you click on it here on the properties, there's a flat pattern display. You can rotate, so you can get that to fit on the page a bit more easily. Alright, so when you're doing that, whenever you're playing around with this part, try not to leave it in the flattened state when you do your drawings. Alright, because that's what happens to your other views. Alright, so always, you know, when you have this part open, just make sure it's in its normal state, folded state. Now, when you convert a part to sheet metal, what happens is, even though the part looks exactly the same, in your assembly, and I'm going to open up my sub-assembly here and go to the default configuration, the references have changed. So some of those mates that were linked to faces of that part, it's now unsure what it's referencing. So you have to edit each of those mates to fix up what was missing. All right, so it's a little bit of a hassle, but everyone will have to do it. There'll also be some mates that you'll need to fix in the general assembly as well, that was relating to, you know, these holes here or these side faces. All right, but it's some good practice for editing mates and fixing errors. So a little bit more on sheet metal. I'll just save those drawings. So sheet metal is a tool that we won't get to use too much. We don't have a lot of time for it, but if you do want to learn about it, I would recommend doing the sheet metal tutorial, which is here, which covers off all of the sheet metal features. So base flange, miter flange, how to mirror, adding and bending tabs. There's a lot of detail in there. I will be able to show you some sheet metal examples a little bit later in the semester. The basics of how it works, there's 2 options. You either build from scratch using the metal tools, or you build like we did with the form bracket using the basic extrudes and cuts and then convert it later. To start with from scratch, your base flange can be any shape, but to do flanges or bends off it, you need flat edges. So I'll start with a basic shape and do a base flange tab here, and create a thickness of 3 millimeters. So your base flange is like your first extrude, all right? But that sets the internal bend radius, which I'm just going to bump up to 3, and the thickness. After you've done that, you get these other options, including edge flanges, okay, where you can select multiple edges, all right, and you have the option to have the bend in a certain position, okay, inside, outside, or right on the edge. You can also change the angles of those edge flanges, and you can even change their sketch shape and size. So if I only want the edge flange in this position, I can do that.
What was that cubic looking relation there?
Which bit? I don't know what you're referring to.
So just near the
That
origin,
one?
there's a relation.
That's convert entity. So
Oh,
that's
right.
an edge that's converted. Basically, this line has been copied into this sketch.
Okay.
So that's where I did that before on the holes. I converted the other sketch. So that's an edge flange. A hem is a bend that curls around. All right, so that might curl around and then go, a certain distance, or it might be flat, just creating a rounded edge, or it might come around on an angle. You've got a jog creates two bends, a sketch bend. Sketch bends lets you create a sketch line. And select a face that's staying flat and then bend from where that sketch is. Okay. There's corner tools there to change gaps between corners or to break corners. So break corner might mean adding a fillet, so rounding off corners. And then there's forming tools as well, and fold and unfold. So sometimes you might want to do a hole, a perfect circle between these two faces here. So I might unfold this bend, create a sketch, create my circle cut, and then I might fold it back. Okay? The difference is that if I just tried to do a cut while it was already folded, it becomes a bit of a weird shape when it is flattened. You can see the difference there between the two. One of the keys with the sheet metal is when you're exporting it. And so the ability to flatten it and then export that file for laser cutting, okay, for production, it's super easy. And we'll go through that stage after we've done the prototyping of the parts next week. All right. Please have a go at the configurations as we've just shown. Feel free to play around with the sheet metal. Continue on with the drawings. There'll be one more demo before class is done. Okay, I'll come back to work out what's best to go on to next. But yeah, just keep working through what you're doing. With the configurations, there is one part which everyone will need to make configurations to, which was the form bracket. Okay, so we can look to that change now. And to give you a bit of an idea about why we need to make that change, I can show you through these drawings here. So these drawings are what we're going to be doing with our pulley. So we're going to be changing a couple of the parts. So we're going to be changing the pivot pin at the top. We're going to remove the washer. We're going to change the form bracket to suit the new size. We're going to customize the wheel, the side plate, and the reinforcing plate. Okay. So what we'll be doing, and we might do this next week, we'll see, but we'll be splitting into groups of 4 or 5, and every person in that group will have at least one part that will be their responsibility to modify, submit files for, and then document when we go to the workshop. Okay? We'll get to that side later. I've got some information here that shows some of the parts and the changes that we'll be doing. So this form bracket, these are the changes that we'll make now in class in that configuration, so everyone can understand how and why. The reason why we have to change the size of this is so that when it's made on the brake press, it can actually be made. So how the brake press works is it takes the flat part here and you put that in the machine, and the forming plate or forming tool comes down on this bend line, and it bends up this edge and this edge at 245-degree angles. Okay, so it goes from flat up to 245s. So as you can see from this drawing at the bottom, I'll just zoom in a bit so you can get to see that view. Okay, from this drawing view here, if you imagine the forming tool come in there, if these edges were any bigger, then it wouldn't be able to bend it the 45 degrees on both sides. Okay, it would prevent it, all right, because this part of material would be hitting that tool. All right, so that's why we have to decrease the total height to 21 for the prototype version. The other thing we'll be doing is changing the thickness to 2 millimeters, because that's the material that we'll have. And we'll also change the hole size, because we're not going to have the bush either. Okay, we're just going to have the bolt. We're just going to change that hole size to 10.5. Right. So we'll go through those changes in a second. The other parts, just to show you now, a bit of a preview about them. So the pivot pin here will be very specific into the size. So this will be cut in a lathe, which means we'll get rid of the loft totally, and it'll be more of a circular type part that's revolved with then 2 holes that are going to be drilled through it. The reinforcing plate, we'll tweak the thickness, and you'll be able to customize the text engraving or cuts around that shape. Same for this one, okay, we'll be changing the holes. And then the wheel, this will be cut from a block of aluminium like we saw. You'll be able to totally customize the pattern of the ribs on the inside and all the fillet detail. Okay. But let's go through this part now, how to do those changes, so everyone can see how those configurations work in reality, all right, with our drawings. So let's go to your sub-assembly again, and just go back to the prototype configuration, and then open up the form bracket part, and here we're going to right click, add configuration, prototype. So, a couple of dimensions that we need to change. The first is the height, is 21. So we're going to edit that sketch of the Boss Extrude 1, double click on the dimension 35, make sure that we get the modify dimension pop up. We can't just click and change the number. We have to get that modify box up so that we can link it to this configuration, and then you can change the size to 21. While we're in this sketch, we can also change the thickness to 2. Again, link it to this configuration.
How do you get that box up? It's not there.
Yeah, so you just have to be very particular about where you click, and what I've found, it's a bit random. I don't know the answer. I don't even know how I did that.
Crazy.
Okay, so maybe if you click, oh no,
I think you just click on the.
no, clicking that doesn't. You need to get the modify box up.
I think this works. Yeah, double click.
Yeah. Anyway, double click on the number. Echo things. Yeah, that works pretty. Yeah, that seems pretty consistent. Yeah, that looks like it works. Very good. Okay, thickness as well. Change that. The other thing we're going to change is that radius. Okay, so we're not going to have a bend radius of 3 millimeters on the inside. It's going to be 1, which is going to be much closer to what it'll be in reality when it's bent on the brake press, which means that this outside radius, if the inside's going to be 1, the outside's going to be 3. So again, change that. Press OK. Now you can see here the thickness is all a bit off and these cuts are a bit funny. That's because of this sheet metal feature. Now in that sheet metal feature you can't actually change the thickness of material. Instead, all we have to do is suppress that convert solid body and create a new one. And in this new one, we're going to change that thickness to 2, change that radius to 1. Now the other features we need to change are in the cut extrude. So this one's a little bit different. You'll notice in the shape now we don't have that semicircle along the bottom, and that hole isn't necessarily in the middle of where that arc would be anyway. So what we're going to do, suppress the cut extrude on the side, do a new sketch and create the new hole, which will be 10.5. Make sure that's centered. And don't have a dimension here, but it's pretty close to that bottom edge. I think it might be, let's go 8 millimeters from center to the bottom. And then features extrude cut through all. And then we're going to add, I think, 5 mil radiuses to those corners. So this is where we can use that break corner tool. So sheet metal corner. And doesn't want to come up for us. Maybe we'll just use fillet instead. 5 millimeters. Select those edges. Alright, so that should be, I think that should be it. To check if you've got that right, go to your configuration manager and click on default again. If you've done everything correctly, the default one should look like the original. And the prototype should look like this. Okay, while you guys are giving that a go, I'm going to sort out the groups for this next project. Okay, so I'll just leave that on screen. Does anyone have any other questions? Like, did everyone get most of that? Yep, I'll help you out if you are stuck.